All right, hey guys, let's take a look at 4.3 part 3. We're looking at circles today. So here are the equations for a circle. X minus h squared plus y minus k squared equals r squared. Lots of letters going on here. So the hk is the center of your circle, and make sure that they are subtracted. It's minus h and minus k. And then the other piece of information is the r. R is the radius of your circle. All right, so let's see if we can do this on number 1. Find the center, radius, and intercepts of each circle and then graph it. All right, so the HK is the center. H and K are what's subtracted from the X and Y. Since I don't see anything subtracted from my X or Y, I can consider that they're subtracting 0. It's like my H and K are both 0. So the center is at the point 0, 0. I'll go ahead and draw that. The radius, how far from the center of the circle to the outside of the circle? Radius is coming from what this is all equal to. It should be r squared. So the radius is actually not a 16. Something squared is 16. In fact, if I consider that as 4 squared, the 4 is my radius. So that is how far away from the center that we go. 1, 2, 3, 4. In all directions. 1, 2, 3, 4. All right, so you get the idea. I'm going to have this, well, much better circle, but yeah, the radius is going to go a distance of 4 from the center. So let's go find those x and y intercepts. I actually could probably do that without some algebra right now. Like I said, I have to go 4 above. 1, 2, 3, 4. There's my y-intercept, and if I go a distance of 4, again, the radius of 4, 1, 2, 3, 4, below, I get another, there's my 2 y-intercepts. My x-intercepts are going to go horizontally, but still the same radius. 1, 2, 3, 4. Okay, so that one is landing at 4, 0. And if I go 4 to the left, I get negative 4, 0. So this one, because it was centered at 0, 0, the x and y intercepts were not too hard. I'm still going to write them down as xy points, my x-intercepts. Let's try to color code this. So x-intercepts were at 4, 0 and negative 4, 0. My y-intercepts on the y-axis were at 0, 4 and 0, negative 4. All right, so then last thing is to graph it, to draw it. I'm going to connect my dots here. Attempt to draw a circle. Okay. All right, so there's our circle. Now, number 2 does not have a center at 0, 0. The center is my HK, H being what was subtracted from the X, K being what was subtracted from the Y. I was subtracting a 3 from the X and subtracting a 2 from the Y. So my HK point is the point 3, 2. I'm going to put that on my graph. There's the center of my circle. The radius, again, this should be r squared. I'm going to treat that as a 5 squared. So my radius is a distance of 5. We're going to go 5 in each direction. And then the x-intercepts. Because the center is not at 0, 0, I think I'm not just going to do it graphically. I'm going to do it more algebraically. My center, or sorry, my y-intercept, x-intercepts, good heavens. My x-intercepts both have a y value of 0. So I'm going to put this y value right here. I'm going to make it a 0. So that'll be for my x-intercepts. All right, so the rest is staying the same, x minus 3 all squared plus, and then I've got a 0 minus 2, so negative 2 squared equals my 25 there. And if I solve this, like I said, algebraically instead of just on the graph, I'm going to subtract the 4 on both sides. All right, and take a square root. This is kind of why I'm doing it algebraically. When I take a square root, I get a plus or minus square root of 21, which the square root of 21 is not a nice pretty whole number. It's a very messy decimal. So when I add this 3 on both sides, keep in mind the 3 is not under the square root. I'm going to leave it outside. But I have a plus or minus, positive or negative, root 21. So this gives me like 2 separate answers. Let's figure out where those are on my x-axis. I'm going to get the decimal form of this. It's a little easier to plot the decimal form. And so I will do my 3 plus the square root of 21. Okay, plus or minus, so 3 minus the square root of 21. These are my two x-intercepts. All right, so like a 7.6, positive 7.6-ish. Here's 5, 6, 7, 8, so like 7.6, a little over 7.5 there. And then the other was at negative 1.6 if I round, a little over negative 1.5-ish. So those are my two x-intercepts. All right, and then let's go find our y-intercept. Very similar. I just set the x value equal to 0. If I'm looking for a y-intercept, my x is 0. So 0 minus 3 is negative 3 squared plus, and then I'm going to solve for this y. All right, so my 3 squared is 9. And then I will subtract the 9 on both sides. All right, so I get a 16. Oh, this is actually a little prettier than the last one. If I take the square root of both sides, square root of 16 is actually a 4. In fact, I need a plus or minus 4. So I'm going to add 2 on both sides. I'm going to do a positive 4 plus 2 and a negative 4 plus 2. So my two different y-intercepts were at 6 and the y value of negative 2. So here's my y-axis. I'm going to put these points on the y-axis at 6, so up here, and then negative 2 down here. All right, and I'm going to also keep in mind that the radius is 5, so I could go 1, 2, 3, 4, 5, kind of off the charts here, but I could go in any direction a distance of 5. 1, 2, 3, 4, 5 up here. I can get some more points. 5 to the left, 5 down. Okay, so all these points should connect in a nice pretty circle. Maybe. Oh wow, okay, maybe I'm not an artist. Maybe I'll go this way. All right, a little better. There we go. There's our circle. Okay, number 3. The only thing that's different here is that they kind of put the y's next to the radius. I'm going to kind of rearrange it. I'm going to take this minus y plus 1 squared. I'm going to add it to the other side. So x plus 3 all squared, and then plus my y plus 1 all squared equals the 4. Okay, so this is kind of the format we were going for. Again, as usual, the center is your HK. It's what's subtracted. This did not say minus, it said plus. So I have to consider that that means you're subtracting a negative. My x value has to be a negative 3. And this plus 1, if it's supposed to be subtraction, it means it's subtracting a negative 1 to get that plus 1. Okay, so there's my HK. And then the radius, again, should be this, not 4, but 2 squared. So the radius itself is a 2. All right, so I'm going to kind of plot my center here. Negative 3, negative 1 with a radius of 2. So I should be able to go up 2 to the right by 2. I'm going to go each direction a distance of 2. All right, let's go find our intercepts. In fact, I'm thinking, looking at this circle, I don't think it hits the y-axis at all. I don't think I'll have any y-intercepts, just a few x-intercepts. So let's do the x-intercepts here, which is when this y equals 0. For every x-intercept, the y equals 0. X's will still be there. X plus 3 all squared plus a 0 plus 1, so 1 squared equals the 4. All right, 1 squared is 1. I'm going to subtract 1 on both sides. So let's see, 4 minus 1 is 3. I'm going to take a square root on both sides. We don't know the square root of 3. It's not very pretty. I do get a plus or minus, though. So I'm going to do pretty much what I did on the last problem. I'm going to add, or sorry, subtract a 3 on both sides, which means that 3 is not under a square root, so I'll leave it outside. But I subtracted it over, hence the negative there, plus or minus this root 3. All right, let's get some decimal forms here. So my negative 3 plus root 3. All right. And then I'm going to do my negative 3 minus root 3. This is my plus or minus. So I got a negative 1.3 if I'm looking at the decimal form. It'll round to like a negative 1.3. Okay, so here's that on my graph. And the other one was a negative as well, negative 4.7 if I round it. So close to a negative 5, not quite there yet though. All right, and I can tell from the graph it's not going to hit my y-axis, but algebraically, let's see what that would look like algebraically. If I make the x value a 0 for every y-intercept, my x is 0. So if I make that a 0, 0 plus 3 is 3, and the rest I will leave alone for now. 3 squared is 9. If I subtract that 9 on both sides, 4 minus 9 is a negative 5. And I have to take the square root to get the y by itself, but here's the problem. Square root of a negative is an imaginary number. I can't put it on the graph. That's why there are no y-intercepts on this particular graph. Okay, so let's connect the dots here. And there's our circle. All right, number 4. This requires a bit more algebra. We got to complete the square. I'm going to put all my x's together. So let's see, I got x squared, I got a negative 4x. I'm going to put those together. And then my y's, let's put the y's together. I got a y squared and a 2y. And I'm thinking this 4, I'm going to put that on the other side. So add 4 on both sides. This will equal a positive 4. All right, so I think we did this a while ago, but completing the square, I want a perfect square. So what I've got to do is cut this number in half and square it. So negative 4 in half is negative 2. Squared is a positive 4. So that's what I add here. That's why I left a blank spot there. I'm going to put a positive 4 there. All right, for this one, I'm going to, again, cut it in half. 2 in half is a 1, and squared, 1 squared is a positive 1, so I'm going to put a plus 1 there. And the whole reason why we did this is because now each of these are perfect squares. So what multiplies before and adds up to negative 4, that would be a negative 2 and a negative 2. In fact, the stuff that I squared is kind of my big hint right there. Negative 2 times negative 2 is a positive 4. Negative 2 plus negative 2 is a negative 4. So this is an x minus 2 all squared if I factor it. Then I got to factor this guy as well. It should be a perfect square. Again, the hint is whatever right here, a positive 1 times 1 is the last number 1, and the 1 plus 1 gives me the middle number 2. Okay, so this is a y plus 1 times another y plus 1, or in other words, y plus 1 squared. Okay, so this is now the format we were going for. Now I can see like the HK, so the center of my circle is at, the, again, positive 2 is my H, negative 1 is the K. So positive 2, negative 1. There's the center of my circle. The radius has to do with what was squared here. So to get a 4, 4 is like 2 squared. So my radius is 2. So I can go a distance of 2 in all directions. I can even go a distance of 2 diagonally if I wanted to. It's just those diagonal distances are a little more difficult to measure. Let's next up look at the x and y intercepts. My x-intercepts are when y is 0. So if I make this y right here 0, then I get my x-intercepts. Everything else I'm going to leave the same. So x minus 2 all squared plus a 0 plus 1 is 1 squared equals 4. 1 squared is 1. So if I subtract 1 on both sides, I'm going to get down to a 3. Square root both sides, which the square root of 3 is not so pretty. I think we had this just a second ago. I do need a plus or minus on my root 3. And I will add this 2 on both sides. This 2 is not under a square root. So I'm going to leave that out front, not under my square root, with a plus or minus root 3. All right, so let's get the decimal forms. All right. So here's my calculator here. I think very similar to what I did before. 2 plus root 3, and then a 2 minus root 3. Okay, so it looks like my x-intercepts are at like a 3.7 and a little bigger than 0, like a 0.3. So 3.7 and 0.3, let's put that on here. 3.7 is closer to the 4. 0.3, super close to 0 right there. Those are my two x-intercepts. The y-intercepts, in fact, I think I already see a y-intercept on my y-axis. I've seen this point already by using the radius, but let's see what we get algebraically here. I'm going to, again, make this x be a 0 for my y-intercepts. X is 0, so 0 minus 2 is -2, all squared, plus my y plus 1, all squared, equals 4. -2 squared is 4. And then I'm going to subtract 4 on both sides, which 4 minus 4 is 0. So I can take the square root of 0. Great, I'll take the square root on both sides. Still 0. And then I will subtract 1. When you take a square root, you usually get a plus or minus. I can't have a positive and a -0. It's not a positive or negative, and so that's just a single number of 0, which when I do 0 minus 1, I get a single number of -1. So it's actually already right there at -1, and we've already got that on our graph. And then we are going to connect these. There we go, there's our circle. Okay. And then last bit here, I think this is our last one. Find the vertex of the parabola and the direction that it opens, then graph the parabola. Okay, so this is not a circle, it's a parabola. What's a little different on it is that the y is what's squared, not the x squared. So it's got to be a horizontal kind of parabola. And the vertex, if it was just x equals y squared, that parent function would have a vertex at 0, 0. Let's see if we did any shifting in any direction. So any addition or subtraction does the shifting, the translating. So that +1 is next to the y. So it's going to go vertically like y's do. And usually the stuff in the parentheses does the exact opposite. So usually +1, positive y's usually go up. But we're going to do the exact opposite. We are going to go down by 1. Again, it used to be a vertex at 0, 0. But if I move that down by 1, we are now down here at 0, -1. And then the -4 on the outside, that has to do with x's. And usually negative x's go to the left, and I'm actually going to do exactly that. I'm going to go to the left by 4. So this is going to then move over left 1, 2, 3, 4. Okay, so there is the vertex. That is the point -4, -1. All right, and then the direction. So if I had a positive x equals some positive y squared, it would face to the right. If I have a negative in front of my y squared, it will be a reflection and face to the left, which I think I do have this negative in front right here. So it will have to open to the left. Okay, so I know it's going in this direction. Then graph the parabola. So right now it's not hitting very many specific points. Let's get a few specific points. Maybe I'll plug in a few numbers for my y. Again, I'm plugging in a number for y, not for x. Usually I plug in numbers for x. But I already know that at -4 I have the vertex. Let's sub in like a -5. So if my y value is -5, oh, that's an x value, excuse me. I should be going for, excuse me, this is a y value of 0 or a y value of -2. Let's try those y values. 0 and -2. I swapped my x and y. There we go. All right, so at -2, I got a -7 for my x. So this is like -5, -6, -7. It's my -2. There we go. And then it'll be very similar. I think it'll probably have the same x value when I sub in a y value of 0, but let's check and see. Maybe. Okay, so instead of subbing in a y value of -2, I'm subbing in an x value of 0. Also gives me a -7. Okay, so my y value was 0, x value -7, same spot right here. So that kind of gives me this shape that we have here. There we go.